All right. In this video, so discuss our question 11. Ngicala ngokukubonga for watching this video, and then in the description below, uzothola ama-links for amanye ama-questions akhona in this question paper. So, question 11 sizokhuluma nge-photoelectric effect, right? But in this case, basiphe like sort of like an experiment being conducted by a group of students. So yeah, right. Question 11 ufundeka ngale ndlela ke. What a group of students investigates the relationship between the work function of different metals and the maximum kinetic energy of the ejected electrons when the metals are irradiated with light of suitable frequency, right? So the work function of a metal, I'm sure, is the minimum energy needed to eject an electron from the metal or the surface of the metal. Right, so in order to achieve that, kumele uthole the right light, the right light source with a suitable frequency. Ukhumbule ama wavelengths, some of the wavelengths on the electrospectrum, on the electromagnetic spectrum, our contain the suitable frequencies for eject ama-electrons. Say for instance in a lead, potassium, silver, ngingasebenzisa mhlambe ultraviolet light, uthola ukuthi la ku-lead i-eject ama-electrons, but ku-potassium naku-silver i-photoelectric effect asi-observe lapho. It's because of the work function yaku-potassium naku-silver lower than the energy being provided by ultraviolet light, right? So ngiyabekisa like ku 11.1 that is defined in the term work function. I'm trying to create a picture of what is meant by work function. So a work function can be defined as, so question 11.1 work function is the minimum energy needed or required to eject an electron from the metal or surface, the minimum amount of energy. If the minimum amount of energy is not met by a certain wavelength being shown only metal surface, ama-electrons angeka ejecteke. But if you exceed that minimum energy, then that's when ama-electrons are ejected, right? Ngoba ngisebenzise ultraviolet kwaphuma ama-electrons ku-lead, lana zange kuphume nala zange kuphume. Then ngasebenzisa mhlambe say infrared or visible light, then uma ngisebenzisa yona ama-electrons are ejected nala. So it means the minimum amount of energy was met on all three metal surfaces, right? Now basically during the experiment, or during the investigation or experiment, ultraviolet rays of wavelength 2 times 10 to exponent minus 8 meters are allowed to fall on different metal plates. So a beam of light emit ultraviolet rays of wavelength. Now basically the corresponding maximum kinetic energies of ejected electrons are measured, and the data obtained is displayed in the table below. So for lead, but discover ukuthi ama-electrons are ejected, but abana this maximum kinetic energy. Potassium this, silver this, and we are gonna from the top row all the way down. We are going the values are decreasing. Right. 11.2. Write down the dependent variable for this investigation. 11.2. The dependent variable. The dependent variable is the variable A dependent on something or another variable, right? So it's sort of like the outcome of the investigation. The dependent variable, it's sort of like the output value. If ngenza so, this is what happens. Yabona? Ngoba since ngiyenzani, I'm showing or I'm shining ultraviolet light on a piece of metal, then this happens. So it means since in an ultraviolet light ngikhombisa on a metal surface and ama electrons are ejected with a kinetic energy of this amount. So it means that the dependent variable ilama kinetic energies law, because I depend on the wavelength or the ultraviolet light ngikhombisa on the metal surface. So the dependent variable it's the kinetic energy. It's the kinetic energy of the emitted or ejected electrons, right? It's the kinetic energy of the ejected electrons. The dependent variable is depending on what you are actually doing during the experiment, right? If in Charlie cabbage, the dependent variable would be how big will the cabbage be, or if in Jala mhlambe ama avocado, the dependent variable would be kuzophuma ngayikhi ama avocado, right? So the control variable. Now the next question, what to write down one control variable for this investigation. Actually, this is supposed to be one controlled variable. The control variable, Lana, it's the variable as you control it, and it's going to adjust, so right. As we get back to the scenario yama cabbages, the dependent variable is the size of the cabbage. In this controller or the control variable, it's the amount of water is what on our garden, as well as the amount of fertilizer on our garden. Like another thing is we control ilama weeds grow around the little cabbage leo, and then even control nama pest infect lama cabbages with, right? So now back to this experiment. The ultraviolet light, it's one thing as we control, right? Instead of using ultraviolet light, I can use something else. Like I can use another light source instead of ultraviolet light. So it means lana ge sikono controller ini the wavelength of light. I can control the wavelength of light, but I cannot control ama results one because they are dependent on the controllable variable. So 11.4. Using the information in the table without any calculation, identify the metal with the largest work function. Explain your answer. So this is the equation. Energy is equal to work function plus kinetic energy, right? So the work function is actually calculated as energy subtract kinetic energy is equal to work function. So the relationship is what? Using the information, identify the metal with the largest work function. So sifuna ukwazi ukuthi yiphi ezoproducer the largest work function, and thina basiphe ini ama-kinetic energies. So do you realize ukuthi from this equation, if kinetic energy increase, the work function is decreasing, right? If I think 7 to this pen, if kinetic energy is decreasing, it means the work function is increase. So there's sort of like an inverse relationship. In case of 10 again, if in a 10 in an energy of 10, subtract say maybe 3, the work function is going to be equal to 7. Again, 10. Let's say now in a kinetic energy of 5, the answer is going to be 5. In an energy of 10 subtracted by 6, my work function is going to be 4. Explain I'm increasing what? Kinetic energy. What's happening to the work function? Decrease. So therefore, which one is a producer the largest work function? So the smallest value is a producer the largest work function. Since if I'm decreasing lana, what's going to happen? The work function is going to increase. So from the photoelectric effect equation, for any given alright, I think it from the photoelectric effect equation as kinetic energy decreases, as kinetic energy decreases, the work function increases. Since what? Since silver has the lowest Ke value, therefore work function will have the highest value. Something like this. We're just going to use this equation to formulate the argument here. Now, Sizala, use the information in the table to calculate the work function of potassium. So calculate your work function of potassium. Work function. Photoelectric effect is equal to, the energy is equal to work function plus kinetic energy. So energy is calculated as energy waves. So it's a formula like one. Okay. Is HF W0 plus, now the kinetic energy for a potassium is 9,58, it's times 10 to exponent minus 18. Now since this energy is coming from where? Is coming from the ultraviolet light. So Komeleng 7 said this formula, the H times F. But since ultraviolet light yam ayina frequency, but instead basipha ini ilo kanje UV light. So basipha wavelength. So the formula kumele change as H times, so represent our F in terms of what? In terms of wavelength. So there's a formula ATC is equal to frequency times wavelength. So mang manipulate this equation, making u F the subject of the formula, and you something like frequency is equal to C over lambda. So therefore sibana that value, work function plus 9,58 times 10 minus 18 H, it's a constant, Planck's constant, 6,63 times 10 minus 34 times 3 times 10 exponent 8, everything divided by lambda, which is the wavelength, but it's 2 times 10 minus 8 equal to 5,8 times 10 minus 18. So the left hand side, my computer is 6,63 times 10 minus 34 times 3 times 10 exponent 8 divided by 2 times 10 exponent minus 8. So total this value 9,9. Asithi 45, asithathe yonke le value, minus 18 is equal to plus 9, 5, 8, 10 minus 8. So the work function is equal to 9,945 times 10 minus 18 minus 9,58 times 10 minus 18. Answer is 9,58 times 10 to exponent minus 18. Voila. 3,65 times 10 minus 19. So this is our work function in joules. So this is our answer for this question. For this question, you got 11.5. Now, 11.6. The final question for this video. State how an increase in the intensity. State how an increase in the intensity of the ultraviolet light affects the maximum kinetic energy of the photoelectrons. Choose from increases, decreases, or remain the same. Okay, you know what happens when the intensity of the light by increase during this investigation for photoelectric effect. What's going to happen if we increase the intensity of the light? Actually, the number of electrons being ejected is will increase, né? But that doesn't affect kinetic energy yalawo electrons azobe are ejected. So lana, why is that so? It's because of the only thing increase is the number of photons from the light source per unit time, but if frequencies will remain the same, as well as the wavelength will remain the same, so the speed doesn't change and the kinetic energy I change now. So our answer will remain the same. Why? Increasing the intensity of light, it only increases the number of photons per unit time, but the frequency but the frequency as it remains constant, and the energy of the photon is the energy of the photons. The energy of the photon is the same. Therefore, the kinetic energy remains the same. Something like this. Maybe when you can produce another set of another argument, you can put up another argument, but it should be producing the same meaning a pumala, right? Same meaning a pumala. The key idea la ukuthi intensity of light I increase kinetic energy. Why is that? Because of the photons aphuma from the light source azo release the same amount of energy, but kuzoba nama photons amaningi strike metal surface yakho. So therefore it means more electrons are being ejected, but not at a higher speed, but at the same speed as before light was intensified. That's the ideal. Ne? You can put it in another way, but it should carry the same idea as the statement. So yeah, this video izophelela lana. This was our last question for this question 11. So thanks for watching. In the description below uzothola ama-link for amanye ama-questions akhona kule question paper. Nangabe uyi-enjoyile this video, please share nabangani bakho, leave a like, leave a comment in the comment section. Uyasikhulume ke. Nangabe une-question, asikhulume in the comment section as well. So thanks for watching. Asikhulume asibonane kule video elandelayo uzobe uyibukela. So thanks ngiyabonga for your support, guys. Yeah, bye bye.